Um, yeah, so if you want to take a look there in Slack, so that's how you drop a table. Use the drop table statement if exists, and then the name of the table. Don't forget the semicolon, and then drop database if it exists, and then you can name the database. So just wanted you guys to have that. I won't walk through it, but just for your FYI there. And then to quit out of the database, out of the PSQL prompt, you can do a \Q. And the final thing I'll show you guys before we hop into kind of a code along, just a couple of bullet points from what we covered this morning. So remember that those \/ commands, such as \l, are commands to navigate PSQL, and they're specific to when you're inside the PSQL environment. We're going to take a look at some ways to write SQL commands, or excuse me, Postgres commands directly from the terminal prompt, where you don't have to go into the PSQL shell. But just so you know, anytime you see that \, you're going to need to be inside PSQL because those are very specific commands. As far as SQL syntax, just some highlights. So remember that all statements end in a semicolon. It's not going to like it if you omit that. White space doesn't matter. So if you have like 2 spaces in between statements or 1 space, that'll be fine. And also the uppercasing. So as I mentioned, so lowercase works, but the convention is to use uppercase for the actual SQL statements, the SQL keywords. And for the most part is for readability, because these things get really dense as you chain them together. So it's just to be very user-friendly for other developers and such. And then always use single quotes when typing out string values. That's just a convention of Postgres. If you use double quotes, it's not going to like it. So if you have any errors when you try to add some data, just make sure that you're using single quotes, because that's what Postgres and SQL rather prefers. So any questions about anything from this morning about relational databases versus non-relational? Any questions? Okie dokie. So unlike Mongo and non-relational databases, relational databases, since there's more structure required, they do require a schema. So every application's database will have 1 or more tables. And you'll recall a table stores information about a particular model. So we would have an authors table that would have rows for individual authors, or a books table that would have rows of individual books. And each table has its own schema, which defines what columns it has and the data types. For each column, the schema defines the column's name, the column's data type, and then any constraints for that problem. And if you remember earlier this morning, we used \D, excuse me. I'll put it into Slack. So this command gives you that \D plus table name. That gives you a little bit more detail on your schema. If you want to see the column name, data type, and constraints, you can use that command right there. So some common data types, pretty much what we've covered in JavaScript already. And let me put a link to some more into Slack if you're interested. The Postgres documentation is also really well done if you want to check that out. But just some examples of data types. You've seen these before: Booleans, integers, floats, text versus variable characters. So remember that varchar, I think that's less than 255 characters. Text would be longer, so a body of text or something. Null, date, and time. So remember, with the relational database, it's very much like an Excel spreadsheet. So if we have columns defined in our schema, that entry can't be empty for a given row. So sometimes, let's say that we have a first and last name for our author, and maybe we don't submit a last name for one of our authors, then in the table, you should see a null value, just as a placeholder, because relational data is very structured. So null is used frequently. Date, time, and many more if you want to check out some more data types there with the link I put into Slack. Constraints are really good to use. So it's a type of kind of formatting or declaring what needs to be required in a particular piece of data before you save it. So this morning we took a look at not null and unique. So those are just a couple. Again, if you want to check out the documentation, there's a lot of other cool constraints, maybe like the length of a string, or maybe a certain number of digits in a phone number or something like that. You can constrain things such as that. Let me show you an example we're going to talk about ERDs here in a bit, but here's what kind of a relational ERD diagram would look like. This is a little bit more complex than is required for you guys' projects, obviously. But we don't use it here in remote, but some other markets use an internal tool called Garnet. Some folks in DC created it. And it's just a way to track homework, attendance, things like that, some administrative features of just running a course. But this is what that data looks like for that application. And I'll also paste into Slack a link to the actual schema up on GitHub if you want to see what this the schema would look like. We're going to be creating these particularly next week. So this is a Rails application. And that's a link to the schema.rb for this app if you want to check that out. And that's what your Rails apps are going to look like. You're going to create a schema RB with all the detail on your underlying database. But just as an example, I just wanted to paste in this ERD diagram. And if you take a look, you can kind of see how the data flows within this application. You know, it all starts with the user, and then those are some of the fields that a user would have. A user has many memberships, so maybe a user belongs to a WDI remote cohort. Maybe that user also belongs to an evening GA class or something, you know, several different types of memberships. Submissions, attendance, obviously, so you'd created an attendance model with some data on that, events, cohorts, assignments, etc. So just wanted to paste that in there. That's just an example of a relational entity relationship diagram. And I'm going to have you guys play around with that here shortly. And actually, Cody, while I'm thinking about it, if you wouldn't mind, could you create some breakouts with the buddies, just so we'll have those on deck? Thank you, sir. So that's an example of what a schema looks like. You guys will probably have maybe 2, 3, or 4 models, you know, something like that. But and obviously they can get a lot more complex. Something like Airbnb or Facebook, you can imagine how many models. That's actually what I'm going to have you guys do here shortly. But before we do that, I want to get you guys started. So for lab time, I'm going to put you guys in the breakouts and have you work in pairs on some. Oh, sorry, Cody. Let me give you hosting privileges. There you go. I'll just make you host. But I want to go ahead and get you guys set up with what we're going to do for lab time. And we're going to take a look at one more little code along and how to seed a database using Postgres and using SQL statements. Then we'll talk about some ERD diagrams, and then that'll lead us up to lab time, hopefully around 4:30. So to start, let's go ahead. If you want to go into your student labs folder, and I'm going to share my screen, and I just want to make sure that we're all set up for lab time here a little bit later. So if you go into your student labs folder, there's a folder in there called library_SQL. So go ahead and cd into that and open it in Atom. And then we're going to walk through this together and take a look at some other features of using SQL and Postgres for our data store. So go ahead and give me a thumbs up when you have that open in Atom and you're ready to rock. I'm going to do the same as well. And for this one, for some of these commands, so earlier when we went into the PSQL prompt, we could do that from anywhere, right? It's kind of a global command. For this particular exercise, we're going to be running some commands from the command line itself. So we want to make sure that we CD into that library SQL folder for these commands. And let's see, 2 thumbs ups. Kieran, I'm sorry to hear that one of your external monitors is broken. That's a bummer.
It's a tragedy. I don't know what's up. I'm coping somehow.
You're a brave man. Okay, 6 thumbs up. That works for me. Let me share my screen and we will walk through some of these commands. So I'm going to share my screen now. Okay, so I have my terminal here on the right, have Adam open here on the left. And again, make sure that you're actually in this library SQL folder, in your student labs folder, because some of these commands will require that we're actually in that directory. Cool, so let's get started. So earlier this morning, I showed you guys how to create a database from inside PSQL, from inside the shell. But you can also do it from the command line. And this is what that looks like. So you can run create DB and then the name of the database that you want to create. So you can create using a command directly from the command line prompt, or if you're inside of the PSQL shell, if you're actually inside of your database, you can also use that create database command. Just pointing out that there's several ways to do this stuff. So let's go ahead and do a create DB. And for lab time, we're going to play around with the library database. Database already exists. So I already have that database. You should not get that error. So go ahead and create it. And then once that's created, let's take a look at what our schema looks like. So earlier, again, we built a schema directly inside of PSQL. But you can also just put it into a file and load it that way into your database. So if you're in Atom, go ahead and click on schema.sql. And this is yeah, go ahead.
Sorry, so I run create DB library, but I first have to do PSQL, correct?
I'm sorry, first you have to what?
Do I have to enter the PSQL first before I create the database library?
You do not. So like I said, there's 2 ways to do this stuff. One is you can run create database inside of PSQL. The way that we're doing this, if you look at the screenshot, it has that little $sign. So that means that we're actually on the command line. And you can see that here the way that I did it. We are not in PSQL at the moment. We're running all of these commands from the command line prompt. So make sure that you're inside your library underscore SQL directory, because now that we're doing stuff from the command line, we do need to be in the directory that we're adding schema and database information to. So make sure that you're in your student labs library underscore SQL directory. Yeah, so earlier when we installed the Postgres app, remember how we copied and pasted that 2-line command bit of code, and we pasted that into the terminal and ran it? So that piece of code gave us access to the Postgres command line interface tools. And these commands that we're going to walk through right now are examples of those tools. For example, we can run create DB and then the name of a database, and that'll create the database directly from the command line prompt. We don't have to go into PSQL to do that. So it's really handy to have these tools.
It was just because when I ran create DB library and I hit enter, it just went to, didn't say like something happened. So I don't know if anything happened or not.
Yeah, so no news is good news.
Okay.
Yeah. If you get any errors, just let me know, but you should be fine. Yeah, let's take a look at our schema file. So if you guys want to take a look at schema.sql, so this should look familiar to what we did this morning. We could go into the PSQL prompt and type this out manually, but obviously it's a little more efficient if we type this in a text editor and then load it into our database to create our schema and the structure for our tables and such. So you guys are pretty savvy at seed files, and this is a similar concept. So when we run this schema.sql, it's going to drop the table, if it exists, the books table, and it's also going to drop an authors table if they exist, and it's going to create a fresh new structure for that database. So we're going to be playing around with authors and books this afternoon. So we're going to create an authors table. We're going to have an ID field, which is going to be a serial type. So serial just means that we want Postgres to manage this field, and it's going to create these IDs sequentially in a serial type of order. So the first author we create will have an ID of 1, then 2, then 3, then 4, etc. So that's what that serial statement means. And then primary key. So remember, primary key, every table that we have, every new entity has a primary key, and that just refers to the identification number or the ID for that particular row. But primary keys, we want to tell Postgres that this is a primary key field so that Postgres will make sure that each ID is unique. You know, we don't want to have 2 authors with an ID of 1 because that's going to screw up our queries and stuff. Then we have a name field with a varchar of 255. So you can actually put constraints on how, you know, how short or how long you want those characters to be. So nationality and then birth year will be an integer. And then for books, we're also going to have an ID field with the serial and primary key constraint. And then this is the really kind of the key to this. So we talked about primary and foreign keys this morning. And so the way that we're going to set our data up, instead of just dumping all of the books that belong to an author into that author table or the author document like we would do in Mongo, the way that we're going to set up this relationship is that we're going to create an author ID field in the book. And so we'll just put the ID of the author that that book belongs to. So if the author, again, let's say we had J.K. Rowling with an ID of 1, then if this book was Harry Potter, the author ID would be 1 right here. And so that's really a key concept. And I think that's something that if you take anything from today's coverage and tomorrow's coverage with Colin, just making sure that you have a good understanding of primary and foreign keys, because sometimes it can be a little confusing, but that's really the key to making these relationships work. Relationships are difficult, you guys. I mean, they really are. All right, cool. So we have a schema, and let's load it into our database to give it some structure. And here's how we can do that. So again, we're going to be running this command from the terminal prompt. So make sure that you're in your library SQL folder. We're not going into PSQL right now. But the way that we can do this is we can say PSQL, and this is to load a schema. So we created that library database. So we're going to say we want the PSQL, the Postgres database, that -d is the database that we want, and the argument after that is the name of the database that we're adding a schema to. So we're going to do something to the library database. And what we're going to do is, if you want to use that little less than symbol, we're kind of pushing the schema.sql file, we're pushing the schema into our library database. And so that's going to instantiate the structure of the database. Now, we could have gone into the PSQL prompt and just like copied and pasted all this garbage. But again, as our schemas get more complex, obviously it's easier just to create a file and to dump it into our database that way. So we can go ahead and run that. And we get a little bit of feedback here. So we run that file, it drops the two tables if they exist, and then it creates the two tables. So it creates the authors and books table right there. So we get a little bit of guidance from Postgres there on the command line. So again, the command we just wrote, it means run the PSQL program, connect to the database called library, then run that schema.sql file inside of that database. So that's going to give us some structure. And then if you take a look right there at the bottom of the screenshot, if you wanted to run this file from inside PSQL, that's the command for it right there. If you're inside of PSQL and you're inside your library database, you could do a \i and then the name of the file that you wanted to run. So again, you could do it from the command line prompt, or you could do it from inside PSQL, from inside the shell. Audrey, what response are you getting?
I'm getting library doesn't exist.
Okay. Did you run create DB library from inside? So remember, from the, I'll put this into Slack.
And mine has actually said books does not exist, skipping table authors does not exist, skipping.
Okay, hold on one second. Okay, so Kieran, take a look at what I just put into Slack and just make sure that you CD inside your library SQL folder inside of Student Labs, and then run that command. You maybe you didn't run that create DB library or something. And then Audrey, let's take a look. Okay. So Audrey, it looks like we didn't finish out that command. So make sure that you do PSQL-D library.
Oh, I did. I did. The first time I made that error, you see afterwards I put help and then I quit and then I put it incorrectly. It's on the very bottom. So I recognize I made that error, and when I went to correct it and put the full command, that's when it told me.
Okay. Yeah, that's fine, Audrey. That table didn't exist, so it just didn't do anything. It just skipped it. So no worries. I already had this database in my Postgres database, so my prompt looks a little different. But yeah, no worries. Looks like it ran just fine.
Mark, do you mind taking a look at my screen?
Sure. Yeah, let me stop my screen share. Sure, go for it.
So this is what it's saying here. I don't know if you can see it.
So Sophia, we want to run schema.sql, not seed.sql.
Oh, okay.
Yeah, not quite there yet. Cool. Very nice. And actually, I imagine all of you guys will get that message that says table doesn't exist, so it's skipping. Because I don't think you have a library database yet. Cool. So Sophia was one step ahead of us. Was anyone else having an issue? Everyone else good to go? Cool.
Same problem, but I just ran the same code again, like the psql/d, and then it seemed to work fine. So I guess
Okay.
you do it twice. Not
Huh.
sure.
Okay.
The second time it didn't give me that notice table books does not exist skipping. It just gave me what you had, the drop table, create table, create table.
The second time you ran it, because the first time you ran it, it created those tables. The second time it ran it, those tables existed, so it dropped it, then re-added it. So that's probably why that occurred. Let's seed our database with some awesome seed data. Again, earlier this morning, we just pasted in some Pokemon stuff directly, which is totally fine, but it's going to be more efficient with our large-scale apps to put that information into a seed file. A little bit easier to edit and stuff. So if you want to take a look at the seed.sql, so it went ahead and gave us some seed data here, making sure that when Postgres starts adding the IDs, that is going to start with 1. And I'll tell you why that's important a little bit later when we get to it. But I'm putting restart with 1. So too long didn't read. With Postgres, if you add, let's say we add 10 authors, and then let's say that we delete all 10 authors, and then we add a new author, that new author is going to start at ID number 11. So even when we delete information from our database, a relational database has to, the integrity has to remain. So even if we delete stuff, that ID number cannot be reused. It's a really important concept with relational databases, so everything stays in sync. So if I do, totally drop my database and start over, I'm just telling my seed data to start with the ID of 1 if you need to. And then you guys can take a look at this data. There's some authors in here. Some of these I know, some of these I don't know. And then we're going to add some books into our books table. And some of this should look familiar. Yeah, go ahead.
You mentioned it has to restart with 1 to maintain. Is that the same for Mongo? Because I never saw a repeat with Mongo.
Yeah, so Mongo, right. So Mongo, each object ID, I mean, there's really no way that that's going to get duplicated. Even if you delete data, I don't even know if BSON object IDs are duplicated, but it's really easy, like, to accidentally put, the number 1 in an ID field. Technically, to answer your question, I'm not sure if object IDs are like accidentally redone. I imagine it's like a crazy order of magnitude that one of those crazy object IDs would be repeated. That's a good question, though. I'm not sure about that.
I noticed as big as they were that they seem to be sequential, that it'll be like A6 and then the next one will be the same thing with like A7.
Yeah, if you look at the documentation, there is a method to that madness. Some of it is some date information with a timestamp in that crazy hash. Those digits do represent something very specific. One section is like a timestamp. Another section may be like the data size of that object. I forget the details. But yeah, it may be sequential. But I imagine it's still pretty difficult to replicate one of those. I could be wrong. I need to check that out. I've never really worried about that because those object IDs are so unique. But with Postgres, given that it's just like 1, 2, 3, 4, 5 and such, it's just something that we need to be a little bit more mindful of. Cool. So there's some seed data. You can check out the authors and books if you like. But now let's run pretty much the same command we just did with our schema. Let's run the command line command to dump those seeds into our database. So we'll still start it with, we're telling the PSQL engine, specifically the library database, we're going to dump this seed file into that. So go ahead and run that. I'll hit enter. And we're going to get a bunch of those inserts. So I forget how many authors are in here, but yeah, so now we have some nice author and book data. And then for lab time, you guys are going to play around with that data a little bit more in depth. But the last thing I wanted to show you, we don't have to run this, but frequently, we talked about relational databases are very much like Excel spreadsheets. And oftentimes, maybe you have an Excel file or a CSV file, comma separated values, or maybe a TSV file, a tab separated value file. Maybe you have like some Excel spreadsheet data with just like hundreds and hundreds of rows and lines and stuff. And maybe you want to dump all that information into your database. It's going to be pretty inefficient, like to try to type that in manually or to make a seed file out of that data. But with Postgres, given that it's very much like an Excel spreadsheet, you can enter your data into some sort of spreadsheet format and then dump that spreadsheet into your database as long as it's formatted correctly. And so I put this command, again, I'm not going to run it now, but just so you can see, if you have some Excel, maybe some, I don't know, maybe you exported some tax information and you want to dump it into a database, or financial information, or anything like that, you can do it directly into the database. And if you look at books.csv, if you look at that file, I just made a really simple example of a CSV file, and you guys can investigate that further if you want to. But I have the fields up here on line 1, and they're separated by commas. And then I just have, Fantastic Beasts and where to find them, comma, the year, comma, the author ID. So in our database, the author with the ID of 2 is going to be J.K. Rowling, because this is the second author in our seed file. So again, it's going to start with the first author, second author, third author. So I just wanted to give you guys that. I think that's a really cool feature of Postgres, that you can do that. Any questions about those commands? Again, you can run commands directly from inside PSQL, or you can do it from the command line. And that's because we installed those Postgres command line tools earlier this morning. And a lot of times it's easier just to do things from the command line versus going into the Postgres engine and going into the database. So I think you'll find that sometimes this is a little bit more efficient and quicker. So I just wanted to show you guys that. Okay, now that we've dumped that seed data, let's take a look really quickly. We took a look at CRUD this morning. Let's take a look at CRUD one more time for review on this data that we just entered. So we'll run through that and then we'll move forward. And you guys will get a lot more practice during lab time, obviously. Here's a table, no pun intended. So you can kind of think about how the SQL commands match up with the CRUD actions and even the HTTP verbs and stuff that we've used. The actions, again, that should look familiar, kind of our RESTful routing, which is going to be really important when we hop into Rails next week. But if you're interested, this is just a little chart on how those CRUD commands match up with the SQL statement. So creating something, we would use insert. Reading something, we can do select. So select star from the database table will just grab all of everything. Update, SQL has the update keyword statement, and then delete would be the delete statement as well. So just for reference, I wanted to show you guys that. Cool. So let's actually see this in action one more time, like we did this morning. So now we will actually go into the PSQL prompt, into the shell, to play around with these SQL query statements directly. So now we can go into PSQL, and then that \C, remember that we can do \L, and that will list all of the databases. I have a ton of databases right now. And when you see that colon, remember that it just means that there's more data. So you can hit the space bar and it'll keep scrolling down. But to connect to a database, it's going to be \C, and we want to play around in the library database. So go ahead and do that. And we'll type these out longhand. Again, just a little bit more review from this morning, and then we'll move forward. So if we want to insert an author into our table, or a book for that matter, we can use our insert command or insert statement. And this will insert a row, meaning a new instance of an author or a book. Paste this in here. There we go. Cool. So we can do insert into, and then the name of our table. Let's just play around with authors. And remember that tables are plural, because tables ideally contain many instances of an author, many instances of a book. So it would be the authors table and the books table. So tables are plural. So remember that the first arguments that we pass in, and the order is very specific. Name, nationality, and birth year. I don't think in our schema, I don't think we required or did a not null constraint. Yeah, so we could just add name if we wanted, or just one of these, but we'll just add all three. So we're going to add some values for these three fields in our authors table. So then we'll pass in the values. So again, I could have done nationality, birth year, then name here. The order really doesn't matter. You just need to make sure that the arguments are in the same order as the values that you pass in, because SQL is going to grab whatever the first argument is you pass in the value. It's going to assume you're passing in the name. The second argument it'll assume is nationality, and so on and such as. So in this example, pass in Adam Bray. Remember that the convention with SQL statements, SQL queries, is to use single ticks for strings. Otherwise, I'm pretty sure SQL will barf on you. It's just the way that it likes it. It's very peculiar. United States of America. And then 1985 is birth year. And then make sure that you put the semicolon at the end, because it does not play nicely if you forget that. So go ahead and run that, and we'll see insert 0 and 1. Christine told us what 0 meant earlier. I'm totally spacing on that, but we inserted one record, one row into our authors table. And then if you remember from this morning, kind of the basic way to grab all of something is select star from the name of the table. That's going to return all the rows from a given table. So if we run that, this is what our data looks like. So we have 9 authors. We seeded 8 of these, and then we just added Adam on the fly. And then I'll paste it into Slack in a moment, but see if you can create, well, I'll just paste it into Slack. You guys can play around with this during lab time. But you can create what's called a result set. So if I had, like tens of hundreds of rows, of columns or fields for my authors, maybe I want to return some results, but I don't want to get all of those columns. I mean, that could, would be really expensive on that query. So what you can do is you can define the exact columns that you want returned in your result set. And so this is how we would do it. Let's say that I wanted to select only the name and the birth year from my authors table. So previously we did this select star from authors. So that returns ID, name, nationality, and birth year. Maybe I don't want all of that information. Maybe I just want name and birth year returned. And so that's a little bit more of a tidy result set right there. So instead of a star, you can totally pass in as arguments, pass in the columns that you do want. And if I'd have done birth year, comma name, that defines the order of the columns that are returned in that result set. And then if you want to return a row or a record that meets some specific criteria, let's say that I want to return all of the authors where the name equals James Baldwin, for example. Now, I think we only have one James Baldwin, so it's a little redundant or whatever, but we could do a select all of the authors from the authors table where the name equals James Baldwin, like so. And then that would return the one row, the one record that we have for James Baldwin. So those are a couple of varieties of ways to read our data using a select statement. And then the last two we'll look at are update and delete. Let's take a look at those examples. So remember, update uses this update and then the set statement. So that $ set was another, that was a similar method or statement that we had in Mongo. We had a $ set. So if we wanted to update an author, we want to grab the author with the name of Adam Bray, and let's make his name actually Adam B. Let's just abbreviate his last name. And then let's also make his birth year 1986. So right now his birth year is 1985, which was an error. So maybe we want to change that to 1986. And so to update a row, we can do update. We're going to be updating the authors table. And we're going to set. So the first thing that we do, we build this update statement, is we're going to put in the updated data first. So in this example, I'm going to set the name to Adam B. And the birth year, we'll make that 1986, where, where the name equals Adam Bray. So this may seem a little backwards. So when we're updating a row, you pass in the data that you want to set. So you're passing in the values for what you want to update. And then at the end, you can do where, and then the value that you're looking for, or the search criteria that you're looking for. And actually, I think, I need to check the documentation. I think you could structure this as long as these SQL statements are correct. I think we could have done update authors where name equals Adam Bray, set, and then the values. I think it would work either way, just as long as we had our SQL statements correct. And so if we run that, we see that one record or one row is updated. And I'm going to hit the up arrow. Let me grab all the authors, and there we go. So Adam is now Adam B, and he has a birth date of 1986. Pretty fun stuff. And then finally, if you want to delete a row, we're going to use the delete statement. So delete from the name of the table. So delete from authors, where the name equals Adam B. So where is maybe you could think of it as the search criteria, maybe similar to .find in Mongoose, and then we would pass in, name, colon, the name or whatever. So let's delete old Adam B. So it looks like 1 was deleted, and then I'll hit the up arrow and let's just grab all the authors again, and we can see that Adam has been deleted. RIP Adam. RIP indeed. Now, I'll show you guys this real quick. Again, to maintain the integrity of the database, if we delete a given row, that ID cannot be reclaimed, or we can't add a new author to that ID. Postgres doesn't like that. So just for example, let me delete James Baldwin, who is ID of 3. So if I delete James, and then we go select from authors, note that 3 has been deleted, but all the other folks maintain their integrity. So this isn't like an array of authors, where if we delete one item from the array, like everything else like kind of shifts up, right? It may go without saying, but these IDs are, these primary keys are unique, and they're very important that it maintains this integrity. So if you looked at this in your database, if you looked at this in one of the GUI interfaces, you should still have an empty row right here, just like an Excel spreadsheet, right? So maybe you delete the information in that row, but you don't remove the row itself. So if you looked at this in that way, I think you would just see null values in that row if you looked in some sort of GUI piece of software. Whew, all right, that was a lot of stuff. Let me stop my screen share. So how are you guys doing with that? Did anyone have any complications or issues with the SQL, running CRUD with SQL? The more practice you get, a lot of these, it's all select, star from, and update and set, delete. In the where statement, obviously use that a lot to specify some criteria that you're searching for. But yeah.
Like you were mentioning, it didn't like it. I just put it in the debugging, it didn't like it.
Which one, Audrey?
Where you were saying if we change the where.
The order.
Yeah, it didn't like that.
Okay. Yeah. Yeah. Thanks for checking on that. I thought I need to check the docs. I thought maybe you could do the order, but yeah, maybe it has to be in that order. So you declare the values you want to update, and then the actual row that you want to update. Yeah, that makes sense. So the order does matter when you structure these. Cool. Any questions about what we did so far? So far we installed Postgres. We've talked about relational versus non-relational databases kind of on a high level. And then we took a look at how to create CRUD actions manually using those SQL commands. So any questions about that? And next week, we're going to take a look at the Ruby library. It's called Active Record. And Active Record is going to do the same thing that Mongoose did for us with Mongo. It's a nice little wrapper that translates our database queries. It's going to do this translation for us. So we don't have to write these manually, although it's really important and cool to have a sense of what is going on under the hood. But we'll look at a little bit of an easier way to do this next week with Active Record. Okay, cool. So let's talk about ERD diagrams. I want to put you guys into breakouts and get a little bit of practice thinking about ERDs with a relational database. So let me Slack out this part of the lesson. It was in the prompt earlier. But let's take a look at this README here for ERD domains. And I don't want to bore you guys going through this whole thing. I'm going to put you guys into breakouts, and if you guys want to just read through this lesson, you guys have already done some ERD diagrams, so I don't want to bore you with the details. The main things in this lesson, it describes how to create the little crow's feet and the particulars on how to connect the models when you're actually creating these diagrams. I'm not super picky on that stuff. There's several ways to do it, as you'll see in the README. But the more elaborate your ERDs, it's really good to have a visual representation to say, like, a user has many recipes, or a user has many movies, or something like that. And so the actual connectors between the models is really important. But I'll have you guys take a look at that. And so there's an example of, let me paste this into Slack. Colin's going to walk us through a little bit more complexity tomorrow, but there's a lot of ways that you can structure your data, and this is really important with relational databases. So when you're thinking about how you want your app data to be represented, just for example, these are just 3 examples. Maybe your data is a one-to-one relationship. And so an example of that would be a country has one capital city, right? So that's a one-to-one relationship. Or a state has one capital or something. A one-to-many relationship may be a location has many cohorts. So remote is not really a good example because there's a lot of locations where you are. But for example, let's say in Atlanta, that's one location, but we've had 7 or 8 cohorts here. So one location would have many of something. And then many-to-many is a really common relationship. An example of that would be maybe a doctor has many patients and a patient has many doctors, right? So a patient has maybe an eye doctor, a general physician, a foot doctor, or whatever. And the way that they're connected is through this third model called appointments. So when you create an appointment, maybe on that appointment piece of data, you put the ID of the doctor and the ID of the patient, and they're joined together because they both belong to that appointment. That's a little bit more of an advanced example, and we'll take a look at that tomorrow and also next week. But these are just some examples of the way that you can structure the relationships in a relational type of data structure. And so to get a little bit of practice, I guess we're going to have four breakouts. So what I want you guys to do is I'm going to put you guys in the breakouts, and I want you to pick one of these apps or entities. So be it Facebook, Twitter, Reddit, Instapaper, Instagram, whatever, Airbnb, Tumblr, ESPN, or if there's something else that you want to try to create an ERD for. But just as a thought experiment, and there isn't necessarily a right or wrong answer. I'm just curious to see how you guys think about your data. Well, let's take about, we'll take maybe 20 minutes, put you guys in the breakouts, and I want you to create an ERD diagram for one of those examples. And just choose whichever one you want. And then we'll come back and then just, you know, walk around the room and see what you guys come up with. But think about the entities for Facebook or Twitter. Like, it can get pretty complex. And again, there's not necessarily a right or wrong way to structure your data, but how would you approach it if you had to build that application? So we'll take about 20 minutes for that. Any questions about what we're going to do for the next little bit? If you want to draw these out manually, that's fine. And as you see in that example, create the entity and then add the fields that you'd want, and then make sure to draw how they're related with the little connector line there. So if you want to use some sort of online free tool, or if you want to draw it out, however you want to do it, it's fine. All right, cool. Cody, you ready to open up the rooms?
They're open.
Cool, thank you, sir. So we'll come back in about 20 minutes.